So far, what we have done is talk about simple linear regression. And remember, simple simply refers to that there is only one x variable, one independent variable that is going into influencing or affecting the y variable, the dependent variable. Many times, however, we think that there's more than a single variable that it can explain how the response variable behaves, how the y variable actually reacts. So to do this, what we can do is we can actually add more independent or explanatory variables, more x's, to create what is called a multiple regression model. So the model looks like this, looks very similar to what we saw for simple linear regression. We have y is equal to beta sub 0 plus beta sub 1 times x sub 1 plus beta sub 2 times x sub 2, all the way out to beta sub q times x sub q plus epsilon. So the betas, again, are unknown population parameters, and the epsilon, remember, is the error term. And so we usually denote the x's with an index counting from 1 up to however many we have. Here we'd have q. So if we had 4 independent variables, we'd have x1, x2, x3, and x4. Right? Q is more just kind of general, so that we could say we could have 2, 3, 4, 7, whatever it is. So this looks very similar to what we saw for the simple linear regression, only now we have the beta sub 2 times x sub 2 all the way out to the beta sub q times x sub q. So then, again, this is the model. So to get the estimated multiple regression equation, we gather a sample of data, and we use that data to estimate the parameters, the unknown parameters, the betas, and those estimates become regular letters that you and I know in the English language instead of Greek letters. So now we have b0 plus b1 times x1 plus b2 times x2 all the way out to bq plus xq. So remember, the epsilon term drops out because we took the expectation of both sides of the model. So when we do that, we have assumptions related to the epsilon terms, the error terms, where we're saying they are normally distributed with a mean of 0 and a constant variance. So it's going to drop out because of those assumptions. And now we have an estimated regression equation. So what we need to do is, if we want to use this equation to predict or estimate a y hat, our guess or our prediction, we need values for x1, x2, all the way out to xq. We already have the parameters estimated. Those are the b0 through bq, right, from the sample data that we did. So then once we do that, we often also want to interpret what the b1 and the b2 mean. So it represents the change in the mean value of the response variable, y, for a 1 unit increase of the independent variable, x sub I, holding the values of all other independent variables in the model constant. So if we're looking at beta 1, we're saying that the estimate b1 is the mean value that the y variable would change if I changed x1 by a single 1 unit increase. So if b1 is positive, it would go up by whatever that value is, that estimated value that we got from the sample data. If it's negative, it would go down as the x variable goes up by 1 unit. And it's also, this is vitally important, that's why it's bold and underlined, it's holding the values of all other independent variables in the model constant. So I can only change one variable at a time, one independent variable, and see how the dependent variable reacts to that change in a single unit increase in that one independent variable.